Okay. Perfect. So my name is Francois Tigeot, and I will talk to you about porting the DRM KMS drivers to DragonFly BSD. I'm a consultant, a software developer, and most of the time a sysadmin. I'm also a long-time X11 and BSD user. I'm a former CCTLD system engineer, and I introduced FreeBSD for the .fr servers. And recently, I became a DragonFly developer. DragonFly is a Unix-like operating system. It was forked from FreeBSD 4 about 10 years ago by Matt Dillon, which is a sort of a computer genius. DragonFly aims to be high performance and scalable. It tries to scale differently to multiprocessor systems than most other Unix-like systems out there. It uses per-core replicated resources, and so many operations are naturally lockless. DragonFly also has some innovative features which can be very useful for specific workloads, such as the Hammer file system, which retains history, is able to do deduplication without a high hardware cost, and is also able to be replicated in real time to remote machines in a master-slave fashion. We also have something called swap cache, which is a second-level file cache, which uses the existing swap infrastructure and is optimized for SSDs. Our graphics speaks more than a few words, so this is a Postgres benchmark showing the scalability of a few operating systems, DragonFly compared to 2 Linux-based operating systems, and DragonFly is on the top. So, speaking specifically about KMS and DRM, there was a first tentative in 2010, which was based on Linux code and a compatibility layer by a student called David Shaw. Unfortunately, he dropped early and failed his Google Summer of Code, but he tried to continue in his spare time during the next few months. He got something somewhat working. He got some results on his hardware, but unfortunately, I never was able to reproduce the working results on my machines. Only got crashes, so it was a bit of a mess. And I think the project was badly managed from the start. So, in 2012, I had to buy a new desktop machine, an Ivory Bridge system, and I couldn't get i9-15 graphics working. So it was a good time to start again. FreeBSD just dropped their own DRM KMS implementation, and since DragonFly and FreeBSD were based on the same code and have many common APIs, I thought it was a good idea to start with FreeBSD code. So in summer 2012, I started to implement the required APIs for the i9-15 driver. By December, the driver was mostly ported. It compiled. It didn't run. Well, at least it didn't run properly. At that point in time, I started working on other projects and left the driver a bit on the side. Other people continued the work and really started to debug everything and find all the little issues and wanted to get it working. And in June of last year, we finally got the i9-15 driver working properly. And the last missing step was something really stupid. It was about cache management. The i9-15 drivers requires very specific cache management on a per memory page basis. And if you let the kernel cache everything, you get crashes left and right, and the GPU doesn't like it at all. The GPU and CPU parts of the i915 hardware are not coherent and want to use the same physical memory with different mappings. We validated the fact that the missing part was cache management by running the system without cache, with cache completely disabled. So we had an Ivy bridge system run at like 50 megahertz. Well, it was really dog slow, but everything ran perfectly. We could see XTerm windows being drawn line by line, but at least they were pixel perfect. So at that point in time, we decided to implement patch support to manage cache on a per-page basis. Last year, I also started working on porting the DTM memory manager and the Radeon driver. The DTM memory manager is required by the Nouveau and Radeon drivers. They were mostly ported by the end of last year, and we still got many crashes and bugs left and right, so it didn't work reliably until this summer. At that point, we discovered we had a big problem. FreeBSD dropped the ball. There were no significant updates to the DRM i915 driver after the initial code drop in 2012. The latest supported hardware was Ivy Bridge, which is now 2 years old. So I decided to switch to Linux for the new i915 upstream in September 2013. And my most important goal was to get some sort of Haswell GPU support. I decided to use Linux 3.8.13. The Linux 3.8 branch is the first Linux version with non-working Haswell support. The DRM Radeon port was also based on Linux 3.8. OpenBSD was also targeting Linux 3.8 point something. And I also have to add, OpenBSD has the best BSD DRM implementation so far. So it was really a no-brainer. Start continuing the work on a Linux 3.8 basis. And it was not an easy ride, for we had many issues with the FreeBSD i915 code base. The DRM code was vastly different from Linux, especially the i915 one. There were some very old parts, and most modern features were from Linux 3.4, more or less. The initial FreeBSD i915 driver was never really based on a specific version of Linux. We always had the tens of thousands of line of code differences, and there were other problems like 2 DRM directories, 2 copies of the DRM i915 drivers, 2 copies of the Radeon drivers, and so on. So when I ran a diff, I found out most code was the same, and with only a few more functions in the DRM2 directory, so it was a big mess. Thousands, tens of thousands of lines of code duplicated. So I merged all of that and only kept 1 DRM directory and 1 set of drivers. The FreeBSD developer also decided to rewrite the entire i915 driver to change its coding style. Apparently, it didn't like the Linux coding style, so we had something like ifret changed to ifret is not null for pointers, or return statements where he added parentheses everywhere, white space differences, whatever. Well, it was a big mess. It was simply impossible to upgrade to more recent Linux versions. The code was too different. He also decided to rename some files. For example, in Linux, there is something called the I2C API, which is used to get information about screens and video connectors and so on. In FreeBSD, it's called IIC, so renamed every file with I2C in the name to the same file with IIC. Well, functions were also implemented in different orders or present in different files. And for a long time, I had a hard time understanding what was going on. And when I finally understood the functions were defined somewhat randomly in the FreeBSD codebase, I just moved them around and I reduced the differences between the FreeBSD driver to the Linux version by more than half. So it's hard to understand what the FreeBSD developer were thinking. So the update process to get to something more Linux-like was run a diff between the two branches, reduce the pointless noise, like white space differences, parentheses, and so on. Once this was done, I could then identify important functional differences, try to implement them piecemeal, which was not obvious to do. So sometimes I had to replace the Linux git history to do it small step by small step. And in general, I try to keep commits small so as not to break everything every time I was trying to modify the driver. So I generally try to use the Linux code base unmodified. And for that, I simply started to implement Linux APIs, which was the same old idea David Chow had a few years ago, a few years before. It was relatively easy for FreeBSD already had a almost complete Linux API set of wrappers. Many Linux headers are implemented as is in FreeBSD in something called the OFED project, which is mainly for the use of InfiniBand drivers. We also implemented locally some Linux APIs in the DragonFly kernel, such as IDR, various different Linux headers, and so on. And I also took many Linux functions directly from OpenBSD, where the OpenBSD guys already did the same thing and tried to use Linux APIs. So, in general, graphic drivers are very complex. About DRM in general, they're fast-moving targets. And it makes more sense to just use the Linux APIs and to implement Linux APIs in the DragonFly kernel rather than try to change the graphic drivers every time to be more BSD-like. So in a way, I'm porting the DragonFly kernel to the DRM graphic drivers and not the drivers to DragonFly. But it's really a no-brainer given we don't have the manpower to do otherwise. So we now have many Linux headers, which are most of the time wrappers to existing Unix or BSD APIs. So really not so complex. This list is even obsolete by now. I've started to add PCI headers also. So we have implementations for most Linux APIs from Linux 3.8. And the goal is to reduce differences as much as possible in the DRM directories and try to have as few differences as possible with the Linux driver code. There's still something where I don't use Linux APIs, and it's locking directives. For each operating system has its own set of locking directives. And, well, in that case, it makes more sense to keep the original DragonFly ones. So it makes it more obvious than the code is not the original Linux code in that case. And where we have important differences, important functional differences, we do it the DragonFly way, so as to avoid crashes and all kinds of bugs. There are still a few difficult spots, and in particular, the gem code in the i915 driver is nothing at all like the Linux code. Well, it was taken from the FreeBSD original driver from 2012, so we have many big functions doing things differently than in Linux. I would like to make that code more Linux-like, but virtual memory management is very sensitive, and if you do things badly, if you change a small detail without understanding what you're doing, you can get all sorts of weird bugs, kernel crashes, hardware reboots, and so on. So it's a very sensitive area of code. We also have the I2C versus the IIC APIs, which work differently. I'd like to have something more Linux-like also here, but, well, it's not obvious to change the code everywhere. And, well, this is basically the two most difficult parts of the i915 and DRAM code in general. So I wanted to implement Haswell GPU support. This was my first and foremost goal with moving to a Linux 3.8 code base. So what I did was basically reduce pointless noise, replace FreeBSD APIs by Linux ones, and then we add important functional differences. The interrupt code was completely different. The ring buffer code was also very different between Haswell, well, Linux 3.8 and previous driver generations. The output management code was nothing at all what we had in previous Linux i915 versions. Haswell is very different from previous GPU generations. Video output ports were moved from the chipset to the CPU die, if I'm not mistaken. And Haswell goes away with many legacy ports, like VGA, and it has digital outputs everywhere. Well, I'm not too happy with that part. For example, we don't find Haswell laptops with VGA ports anymore. But, well, we had to implement that. Some hardware people also had the bright idea of changing the specific cache attributes in the GPU patch tables for Haswell. So when I first implemented the first 5 items, I had some Haswell GPU support working. I was able to display graphic applications and have the X Windows system work and display X terms also, but Windows didn't appear normally. Well, the wireframe appeared instantly, and the window content was being drawn small step by small step with little rectangular areas. And it was really like a cache being drained, and that was exactly that. We had to add as well specific cache attributes in the GPU patch tables. So Haswell is different from previous GPU generations, but for no good reason, but well, it had to be done. And Haswell GPU support was finally working reliably in DragonFly by the summer, in August of this year. I also have to say a few words about Userland. DragonFly used the PKG package management system until 2013. PKG is a soft of system-independent package management. it works a bit like FreeBSD ports. You change directory to a specific application directory, you type make install, the systems downloads the application sources, patches them, builds them, and installs the results. Well, okay. So the problem is we only had X.Org server 1.6. It was too old to be able to work with DRM and KMS drivers. And well, for unrelated reasons, we also switched to dports in 2013. Dports is based on FreeBSD ports, an additional layer, automatic tests, and validations. And it was much better for we were able to get Xorg server 1.12 and contemporary software. So finally, an Xorg server version which worked with KMS. The problem is FreeBSD ports are beginning to lag. Updating Cairo from 1.10 to the current version took years. FreeBSD is still using an old version of the XF86 video Intel driver, which has some bugs and on recent GPUs. So I had to create a locally managed port of the 2.19.9 something to the Intel driver. And I hope it won't become necessary for other software elements. So right now, we have the DRM i915 driver, mostly in sync with Linux 3.8.13, except the gem code. Well, it's mostly a matter of speed at this point in time. Everything is functionally equivalent to Linux, at least for the most important parts. We have DRM Radeon, mostly in sync with Linux 3.8, which is the same version of the Radeon driver, which is in FreeBSD. The DRM TTM memory manager is based on Linux 3.9, and the generic DRM code is a complete mess. A few parts were updated to be able to work with the Linux 3.8 based drivers, but other parts are much, much older. Much older than Linux 2.6.26 in some cases. So in the future, I like to synchronize the DRM code itself to Linux 3.8 something, which is required for some features like DRM prime, DRM master, and so on. Well, more or less the same things Jean-Sébastien spoke about on FreeBSD. And instead, upgrading the DRM drivers to more recent versions. Right now, we have finally a working TTM memory manager. So porting Nouveau is also a good idea. We also have a small issue where once we start running X with DRM KMS drivers, the GPU is not restored to a VGA compatibility mode and will lose the 80 by 25 VGA text mode. So if we quit X.Org, we get a frozen image or black screen, and we no longer have the traditional 80 by 25 text mode. So I'd like to restore the VGA text mode, or maybe implement a graphical TTY layer like some other operating systems do. So patches are floating around. It's still a bit undecided at this point in time. Finally, I'd also like to thank some developers. So FreeBSD was used for the initial driver porting. So Konstantin Belousov was the guy who implemented the original DRM i915 driver in FreeBSD. And the necessary bits to get the memory managers working. Alexander Kabaev starting to port the Radeon driver, and Jean-Sébastien Pedron, which did the previous presentation, finished the port of the DRM Radeon drivers and fixed critical bugs in the TTM memory manager. On the DragonFly side, I ported the bulk of the DRM, i915, TTM, and Radeon drivers. A German guy called Johannes Hoffmann made i915 finally work reliably. Matt Dillon, which is our project leader, was also involved in making these drivers work reliably. In particular, with the virtual memory system, he implemented pod support in the kernel and fixed critical VM bugs. And we have also Joris Giovanelli and Marcus Pfeiffer, who fixed critical bugs and spent a long time investigating some crashes and memory corruption issues. So, I'm done. Do you have any questions?
Did you run any benchmark to compare to the Linux drivers? I could have had the same question for FreeBSD.
No. At this point in time, I did not run any benchmark. I'd like to continue synchronizing the code before trying to run any formal test. Generally speaking, the drivers are now much more stable than what we had previously when we started to pod them and they started to run 1 year ago. Benchmarks are probably not a good idea at the moment for our memory managers still do things like very old Linux versions, and in particular we don't use scatter gather support and so on. Memory is still managed page by page individually, so I expect to see a big speed drop in for operations which have to remap a huge amounts of pages, for example. But generally speaking, today X.Org operations seem pretty fast. Well, it's not a problem for day-to-day use.
Any other question?
I'd like to add that on FreeBSD we didn't run any big benchmark either, but we are using Piglit to check that the drivers are working, and Piglit is running quite fine. And a second point, some people asked in the past few days if we were working together with other BSDs. Yes, we are trying to share code, and especially with DragonFly BSD. We will probably work more closely, especially on the update of the DRM device-independent code, and probably the Nouveau driver too.
Okay, well, I guess we can move to the next talk. Thank you very much.
Okay, thank you.